Falcon, status.
Engaging.
Let me read the question now. Solution by scale drawing is not accepted. Diagram 5 shows triangles ABC and CDE. So this is the triangle ABC and CDE. Okay, straight line AE intersects the straight line BD at point C. Okay, this is the straight line AE. Okay, intersect at the straight line BD at the point C over here. Okay, it is given that C is the midpoint of AE. Okay, C act as the midpoint for the straight line AE, and BC is to CD is equals to 2 is to 3. Okay, the ratio. So from here, the question asks us to find the coordinates of D and the area in unit square of triangle CDE. So this is for the question part A. Okay, for the part B, point P moves along the circumference of a circle with diameter AB. So the question asks us to find the equation of the locus of P, and they ask us to determine whether the locus P passes through point C or not. Okay, so this is the oral question. So without further ado, let us begin our discussion for the question part A by begin with the part 1 and then followed by the part 2. Okay, so from here let us start. Okay, for the question A part 1, we are required to find the coordinate D. Okay, so the first step before to find the coordinate D is we need to identify the coordinate C. So how to find the coordinate C? The question already gave us the hint that C is actually a midpoint. Okay, C is actually the midpoint of AE. So coordinate A we already know, which is 3, 2. Coordinate E also we already know, which is 7, -6. So from here we can easily find the midpoint. Okay, so how to calculate the midpoint? Okay, I'm going to show you now. So from here, coordinate C, okay, it's very simple. So from here, so 3 plus with 7 and then you divide with 2, that's for the x coordinate. 3 plus with 7, okay, divide with 2, okay, and then 2 plus with -6 and then you divide with 2. 2 plus with -6, okay, you divide with 2. Okay, so from here we can easily get the coordinate C. So let us start with the x coordinate. So 3 plus with 7 you get is 10. So 10 divided with 2 you get 5. Okay, and then continue with the y coordinate. 2 plus with -6, from here you get -4. -4 divided with 2 you should get -2. Okay, so this is our step number 1 by identifying the coordinate C. Because why we need coordinate C? Because coordinate C is the intersection between straight line AE and straight line BD. By finding the coordinate C, that will be useful for us to find the coordinate D, because as you can see here, BCD is a segment line. Okay, whereas point AE is divided through equally, as C act as a midpoint. Okay, so there is a difference between line segment and the midpoint lines, guys. Okay, so from here we already identify the coordinate C. So let us underline this. Okay, so once we get the coordinate C, the next step is I'm going to sketch a line segment. Okay, a very simple sketch. So from here, so let me write this as B and this region as C and this region as D. Okay, because this is a line segment, so I wanted the distance between BC should be shorter than the distance between CD. Okay, so from here B coordinate is given by the question is -1, -8. Okay, C we have already found just now, which is 5, -2. Okay, D is the one that we're going to find out, and it's split in the ratio of 2:3. Okay, so from here, in order to solve this question, you need to apply the line segment formula. Okay, the line segment formula, usually what we encounter with, they'll give 2 endpoints and then they will already give us the ratio, and from there we need to find the segment. Okay, the middle one, on should be say the in between coordinates, but in this case the in between coordinate they already give, the first end coordinate they also give. We need to find the other end coordinate. Okay, it's the other way around. So from here, how to do it? It's very simple. So from here, the working still the same. So from here, let us start with the x coordinate. So from here, -1, okay, times with the opposite ratio. So from here, opposite ratio is 3. So -1 times with 3. So from here, the other end, x coordinate, do we know? We don't know. So we just write it as x. Okay, x. Okay, and then it times with the opposite ratio. What is the opposite ratio? In this case is 2. So x times with 2. Okay, and then you divide with the summation of ratio. Summation of ratio in this case is 2 plus 3, 5. Okay, so you calculate this, you should get equals to 5. So you understand what I mean, right? Okay, so let me underline the fraction. Okay, let me place it over here. So this is for the x coordinate. So from here, let us focus on the y coordinate. Still the similar working. So -8 times with the opposite ratio. Opposite ratio in this case is 3. Okay, plus with the y coordinate for d, we don't know yet. So from here, we just write here as y. Okay, and then times with the opposite ratio. In this case, the opposite ratio is 2. Okay, and then you divide with the summation of ratio, 2 plus 3 or 3 plus 2, or whichever way it is, you should get 5. Okay, so you calculate this, you should be getting equals to -2. Close bracket. Okay, so let us perform the calculation for x and y simultaneously. Okay, so from here, -3 plus with 2x over 5 is equals to 5. Okay, we are done with the x coordinate. So let us move on to the y coordinate. So -8 times with 3, you get is -24. Okay, plus with 2y. Okay, and then you divide with 5. Okay, is equals to -2. Okay, continue our working. So from here, -3 plus with 2y, -3 plus with 2x is equals to 25. Okay, so from here, -24 plus with 2y is equals to -10. Okay, so from here, we will split our working. 2x is equals to 28. Okay, the -3 from the left hand side, you move it over to the right hand side. So 2x equals to 28. So from here, you get your x coordinate is equals to 14. Okay, we are done with the x. Now let's move for the y. So from here, 2y is equals to -10 plus with 24. So -10 plus with 24, you get is 14. 2y is equals to 14. So y, how to get the y? 14 divided with 2. So from here, you get your y coordinate is equals to 7. Okay. So this is the x coordinate and this is the y coordinate. Okay, but it will be better if you write your final answer in this way. Okay, therefore d, the coordinate of d is equals to 14, 7. Okay, this is better. Rather than you leave it in this way, to be safe, you just write and leave your answer in this way. Okay. So we are done with our discussion for the question A, part 1, by finding the coordinate D. Okay, so we are done with the question A, part 1. So let us move our discussion for the question A, part 2, where it required to find the area in unit square of triangle CDE. Okay, so from here, now to find the area of triangle, okay, it's very simple since we have already find the coordinate D based on our discussion of the question A, part 1. So from here, let us begin our discussion. Okay, so in order to find the area of triangle CDE, so I'm just going to write here area CDE. Okay, regardless of area of triangle or polygon or whatever shape it is. Okay, so it will be 1 over 2. Okay, and then within the modulus. Okay, now I'm going to teach you how to solve the question. Okay, so since we are dealing with the triangle CDE, okay, the direction on which way you want to take the coordinate, okay, it doesn't matter if you want to take it counterclockwise or clockwise. Okay, it doesn't matter, but make sure that if you start with coordinate C, let's say for example, if you start with coordinate C, you must end with the coordinate C. Okay, still don't get it? Okay, don't worry, I'm going to explain to you one by one. Okay, so in this case, I'm going to arrange the working in the clockwise direction. Okay, C, D, E. Okay, so from here 1 over 2, okay, and then times the modulus. Let us start with the coordinate C, which in this case coordinate C, yes, C, right? Okay, so let us start with the coordinate C, which in this case the coordinate C is 5 comma negative 2. Okay, move on with the coordinate D, which we have find just now 14 7. Okay, and then we move on to the coordinate E, which in this case coordinate E is 7 comma negative 6. Okay, and remember, if you start with coordinate C, you must end your working with coordinate C. So C, D, E, and then one more time you have to write C, coordinate C over here. Okay, 5 comma negative 2. Okay, you close modulus. Okay, let's say if you are dealing with triangle, that means you have to write for 4 times. Okay, so let's say you're start with the coordinate C, coordinate D, coordinate E, and one more time you need to write the coordinate C. Okay, which means that if you start with coordinate C, you must end with coordinate C. You could be starting your polygon with coordinate D. If you start with coordinate D, for example, I'm following in the clockwise direction, so from here D, E, C, and then you must end your coordinate with D again. Okay, then only it will be correct, otherwise you will get a wrong answer. Okay, so it is important for you to start and finish in the same coordinate. So from here, so let us perform the working. So from here, area CDE is equals to, okay, so 1 over 2, okay, times the modulus. Okay, let us perform the calculation one by one. So we're going to start with the top side, top to bottom. So 5 times with 7, you get is 35. Okay, and then plus with 14 times with negative 6, okay, you get is negative 84. Okay, and then end with 7 times with negative 2. Okay, so from here plus with negative 14. Okay, close. Okay, we have already done from the top to bottom side, and now you need to continue the bottom to top. Okay, so from here, from bottom to top, you need to minus them. Okay, so minus with, okay, close square bracket, negative 2 times 14, you get is negative 28. Okay, and then plus with 7 times with 7, you get is 49. Okay, and then plus with negative 6 times with 5, you get is negative 30. Close bracket. Okay, and don't forget to close the modulus as well. So from here, continue. So from here, area CDE, you calculate 1 over 2, okay, modulus. So from here, this side you calculate, you should get is negative 63. Okay, over here you calculate, you should get negative 9. Okay, close modulus. Okay, so from here, continue, area CDE. So from here you calculate, you get 1 over 2, close bar. So negative 63 plus with 9, so from here get is negative 54. Okay, the modulus symbol is anything which you have negative or positive, you will get back your positive answer. Okay, regardless of any symbol, positive or negative, your final answer will be positive. Okay, so from here, since inside here is negative, you should get back 54, and then 54 you times it 1 over 2. From here, your final answer, area CDE, is equals to 27 unit square. Okay, so this is your answer for the question A part 2. Okay, so from here, I hope you understand the working that I've shown to you for the question A. So from here, let us move on to our discussion for the question B. Okay, which we start with the question B part 1. For the question B part 1, we are required to find the equation of the locus of P. Okay, so let us read the question again. Point P moves along the circumference of a circle with diameter AB. Okay, they highlight here diameter AB, and then they mention that the point P is moving along the circumference of the circle. So from here we know that our locus is actually a circle. So locus is actually a moving point. From here it is moving in a circular direction, which has the diameter of AB. So what is the diameter AB? So this is the diameter AB. Since it is moving in a circle, the first step what we need to do is we need to find the midpoint of AB. Okay, so that will be our major step on solving this question. So we find the midpoint of AB. So once we find the midpoint of AB, so using that midpoint, we're going to find the distance. Because they only highlight here diameter AB, we need to find the radius. Yes, so from here, once we find the distance of the radius, and then from there we're going to equate it to the locus from the diameter, from the distance A to the radius, or B to the radius. Regardless from where, you should get the same locus value, because it is a moving point, is in a circular moving point. Okay, circular moving point means radius means you should have an equal distance direction over here. So from here, our first step will be finding the midpoint of AB. Midpoint of AB means, in this case, let us denote it as letter S. Okay, so from here, just write here midpoint AB, or in this case we write it as S. Okay, so from here, 3 plus with negative 1, okay, and then divide with 2. That's for the x coordinate. Okay, move on to the y coordinate. 2 plus with negative 8 divide with 2. Okay, close coordinate. So from here we're going to write it as S. Okay, so from this step onwards, because why I write midpoint AB in the bracket S, so we set the S as the midpoint of AB. Okay, just want to clarify over here. So from here, 3 plus negative 1 get is 2, so 2 divide with 2. So from here you get is 1. Okay, 2 plus with negative 8, you get is negative 6. Negative 6 divided with 2, so from here you get is negative 3. So this is your midpoint S. Okay, this is our step number 1. Okay, for the next step is we need to find the distance of AS or AB. So technically they are the same. Okay, distance of AS is equals to distance of BS, because it's a midpoint, right? Okay, they should have the same distance. So from here, what we're going to do is we're going to check from the distance A. Okay, so from here, calculate distance AS. So from here, to calculate the distance AS will be equals to 3 k minus 1 squared, k plus with 2 minus negative 3 squared, close bracket, negative 3, okay, square. Okay, now it's better. So from here you calculate this, you should get your distance AS is equals to square root 29 unit. Okay, why I leave the answer in the surd form? Because in our working later on, the surd will be automatically be removed. okay, and then you only left with 29 in the working. Okay, so from here I hope you understand. So that is the reason why I didn't give an exact value but leave the answer in the set form. Okay, so from here this will be our second step. Okay, so we have already identified the midpoint and then we already calculate the distance. Okay, now we already know the distance, which in this case the radius of the locus, which in this case is a circle. Okay, now let us calculate the equation of locus P. Okay, so from here, a moving point P, we don't know exactly where is the location, so we're going to set it the x and y, I mean the coordinate of the moving locus P is xy. So from here, x, okay, we're going to minus with the midpoint. In this case, the s will be x minus 1 square, okay, and then plus with y minus negative 3. In this case, will be y plus with 3 squared, okay, and then you square root it. Okay, you should get equals to square root 29. Okay, now you get it why I leave my answer in set form, because in the upcoming step we're going to square both sides to eliminate the set form. Okay, so for the next step what we're going to do is we're going to square both sides. Okay, we're going to square both sides, so you're only left with x minus 1 squared plus with y plus 3 squared is equals to 29. Okay, for the next step what you're going to do is we're going to expand the bracket for the x and y respectively. So let us perform the expansion. So from here you should get x squared plus with 2x plus with 1 minus, sorry for the mistake, so x squared minus 2x plus 1. So from here plus with y squared plus with 6y plus with 9 is equals to 29. Okay, so from here you calculate this and then you should get your final answer. Okay, for the arrangement of the locus we're going to start with the power of 2. So x squared plus with y squared minus with 2x plus with 6y. Okay, and then towards the end only we're going to include the numbers. So from here let us calculate the numbers. 1 plus with 9 you get is 10. Okay, and then 10 minus with 29 you should get is negative 19. So from here this is your final answer. So this is your equation of locus P. Okay, so we are done with our discussion for the question B part 1. Okay, let us move on to the question B part 2. Okay, for the question B part 2, they ask us to determine whether locus P passes through point C or not. Okay, let's say for example we have point C over here. Now we need to check whether point C is passing through the locus P or not. So how to check? Very simple, we just use the coordinate C and then substitute back into the equation of locus P, and from there we can identify whether it is passing through the locus P or not. Okay, very straightforward. Okay, so from here substitute coordinate C into the locus P. So from here we can check easily 5 square plus with negative 2 square. Okay, because the coordinate is 5 comma negative 2. So from here let us continue minus with 2 comma 5, I mean 2 in a bracket 5 plus with 6 in a bracket negative 2 minus with 19. Okay, let us calculate. So 5 square from here is 25. Okay, negative 2 square you get is 4. Okay, negative 2 times with 5 you get is negative 10. 6 times with negative 2 you get is negative 12, and then here you have negative 19. Okay, so from here 25 plus with 4 is 29. 29 minus 10 you get is 19. 19 minus 12 you get is 7. 7 minus 19 you should get negative 12. Okay, by right, if it is by right, if coordinate C passes through locus P, you should get exactly 0, but then here you have a value here, and negative 12 indicates that it is not equals to 0. Okay, if you want to know whether a moving point passes through a locus P, your final answer should be exactly 0. If you didn't get exactly 0, that means that it doesn't passes through the locus P. Simple as that. Okay, since in this question you get here negative 12, so we can conclude that point C does not intersect through locus P. So this is your final answer. Okay, so let me scroll up. Okay, we have come to the end of the discussion for the question 9 SPM 2021 at Maths paper 2. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming at Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.